All right, so the great thing about this problem is you can use either calculus or algebra. And the algebra that we're talking about here is basic first year algebra. So we're not talking about complex algebra in order to solve this problem. So again, depending on your math skills, you may want to use calculus or you just have to break out some basic algebra. So what is the problem? Well, we have a ball situation. So some sort of ball is being thrown and it's going to kind of go up and then it's going to go back down. And what we're trying to determine here is what time, okay, in seconds, will the ball be at its maximum height? Okay, so that is the question. So the ball is going up, up, up here, and then at some point, at some time, okay, in terms of seconds, it's going to be at its highest, and then of course it's going to be going back down. Now, what we have here is a function that describes the motion of this ball. So our y-axis here is represents the height of the ball in feet, and our x-axis represents the time displaced in seconds. So at this time, the ball is right here. At this time, in seconds, the ball is right there. At this time, the ball is right here. Now, at some time, the ball is at its highest point, and then obviously, as time ticks on, the ball is going to come back down. All right, so you're definitely going to have to know a thing or two about either algebra or calculus, and this particular function describes the motion of the ball. And this function is h of t is equal to negative t squared plus at plus 25. All right, so if you can determine the time of which or when this ball is at its maximum height, well, that is fantastic. Feel free to use a calculator, but put your answer into the comment section, and then we're going to get into the heavy duty math to solve this problem. But really, it's I'm not going to use calculus to solve this problem. We're going to be using basic algebra, but I will explain a little bit about the calculus that you could use if that's what you're going to use. All right, but before we get started, let me quickly introduce myself. My name is John, and I have been teaching middle and high school math for decades. And if you need help learning math, well, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, or if you just enjoy this content, make sure to like and subscribe, as that definitely helps me out. All right, so again, we have a function here. And a function is basically a mathematical description of this curve right here. Okay, so or this arc of the ball. Okay, it's describing the motion of the ball. And as we kind of already talked about here, this axis is the time. So as time goes on, the ball is going to get higher and higher and higher. And then as time continues to go on, the ball is going to go back down. We're looking for what time. Okay, not the height. That's a separate question. And if you want to find the height, I'll show you the answer to the height later in the problem. But what time is it, or how many seconds into this ball being thrown will the ball be at its highest? Okay, so let's take a look at the answer. The correct answer is 4 seconds. Now, if you got this right, you definitely get a happy face, an A plus, and 100%, and a certificate of excellence. Matter of fact, if you were able to answer this you were in one of my math classes, I would just say take the rest of the year off. I have no idea how you got this right. You're probably watching that guy on YouTube, so that is fantastic. So let's get into the math and don't be intimidated by this. If you're like, oh boy, Mr. YouTube Math Man, this is too complex for me. I'll never be able to understand this. Yes, you will, and yes, you can. But let's first just talk about the general setup. All right, so we have a ball, and the ball is getting, being thrown up in the air, and of course we have gravity, having this effect on the ball. So we're looking for the maximum height of the ball. Okay. Now this point, this maximum, okay, is actually, we're going to use another word here called vertex. Okay, the vertex is a specific location of this point. Now, what we need to notice is that we have something called a function. Okay, now functions in mathematics is a huge topic, but this is what we call a quadratic function. Now, notice here we have a t squared. This second power indicates this is a quadratic function, power of 2 polynomial, and this negative sign means that we have a graph of a quadratic function that's upside down. So I'm going to go ahead and just do a quick review of quadratic functions because you probably heard of quadratic equations. So let's do a fast review of these graphs of these quadratic functions. So here we have x and here we have y. So when you have a basic quadratic function, well, maybe something like y equals x squared plus 2x plus 3. Now I'm not going to graph this, but this is a quadratic function. Again, it's a polynomial to the second power. These things here have a respective graph, and that graph is called a parabola. Okay, so it basically goes like this. That's a basic parabolic shape. It's effectively a U shape. But we can also have for these quadratic functions, parabolas that go upside down like this. And this is our situation in this particular problem. So the way you make a parabola go upside down is you put a negative sign in front of the x squared term. Now in this particular problem, we're not dealing with the variable x, we're dealing with the variable t. And if you notice here, where we have x and y. So this axis is the x-axis, and this axis here is the y-axis, okay? But in our problem, this axis right there represents time, and the y-axis represents height. All right, so what we're trying to actually do here, being that we have a parabola, is we're trying to find that point, okay? That point being the vertex. So here is some sort of parabola. At this point right here, the very top is the maximum. Okay, if we had a parabola down here, this point, which is the vertex, is the minimum. And this specific point, this vertex, is an xy point. In other words, we can get to this point by determining the x and y coordinates for the vertex. So really what this problem boils down to is finding the vertex of this quadratic equation. All right, so we're going to be doing some, I don't want to say too complex algebra, but I'm going to show you some, show you a formula here in a second. But before I do that, let's talk about how you could use calculus to solve this problem. I'm not going to actually show you the full calculus, but I'm just going to explain it because I did mention it in the beginning of this video. All right, so here is a function, and for those of you that are like, hey, Mr. YouTube Math Man, I know calculus, and I could do this really easy. That is fantastic. So in calculus, you basically learn two big concepts in basic calculus. The first is integration, and that's finding like the area underneath a curve. Okay, so we have a curve. If I wanted to find this area right here, I could just integrate from this point to this point underneath this curve. I'm certainly not going to get into this right now, but just real basic kind of overview of calculus, right? So one big thing one of the big problems that calculus solves for us is finding the area of strange objects that we don't have formulas for, something like this. But another thing that calculus is awesome for is something called the derivative. Okay, so here you can actually find h prime or h prime of t. That's the first derivative of this function, and that basically will tell us the slope anywhere along this function. And what we can do is figure out when is the slope of this parabola 0. Okay, now slopes of lines work this way. This, as the slope is increasing, oops, no, I did this wrong. As the slope is increasing, when you graph a, we're talking about a basic line like y equals mx plus b, that's a positive slope. When a line is falling in this direction, that's a negative slope. When a line is perfectly flat, that is a slope of 0. Okay, so we can calculate something called the first derivative. It's really super easy. Matter of fact, I'll just do it right now because it's that easy. We're going to take this 2 times this -1, so that's -2t. We're going to drop this down by 1 plus 8. Okay, so we're going to take this t to the first, and this is our first derivative, h prime, and literally we could set this equal to 0. Matter of fact, I'm going to do it because it's that easy. We have -2t plus 8 is equal to 0. -2t, we're going to solve for t here, is equal to -8. T is equal to 4. Okay, so solving this equation for 0, meaning that what time or when is the slope of this arc flat? 0. Okay, we just solved for it. It's 4 seconds t is equal to 4. That's an application of the first derivative in calculus. So a lot of you are like, all right, Mr. YouTube Math Man, you haven't even got to this problem and my hair is already standing up. Well, take it easy because I just showed you calculus. Now, you may never take calculus, but if you have basic algebra knowledge, then you'll be able to understand how to find the vertex. So let's go ahead and get into the rest of this problem. And what we need to first understand is that we have a formula for the vertex of a parabola, right? So here could be a parabola. This top point could be some xy point, but that's the vertex. Or we can have a parabola this way, and this point right here could be the xy point, and that's the vertex. But the formula for a vertex, whether it's this way or this way, is this. It's minus b over 2a. That's our x coordinate. And our y coordinate is basically we have to evaluate the function with this answer. So h of minus b over 2a. So don't be afraid of all this math. It's going to make sense in just 1 second. So let's go ahead and actually start calculating the vertex of our parabola. Now, my little drawing or diagram right here is not actually realistic in terms of our actual function. Okay, you'll see why here in a second if I can erase all this mess. Okay, so if we look at this, it appears that at time 0, okay, and this would make sense if we think about this ball, right? So I just kind of drew it this way so I can make this distinction. So here is the ball at time 0, here's the height. So it's almost like we are throwing the ball from like ground level, right? Like on the ground. And we throw it up like so, and then it goes back down to the ground. But that's not actually what this function is describing. Okay, the function is describing this situation. And this is important because, I want to teach you as much as I possibly can in this little video. So at time 0, okay, where is the ball? Okay, so let's use this function and plug in 0 for t. So when t is equal to 0, what is the height? Well, we're going to do some basic function math here. So we're looking for h of 0. All right, so we're going to replace this t. T represents time in seconds. And when we plug in this 0 into our function, this rule here, it's going to tell us the answer. So this is going to be negative 0. We're replacing the t with 0. 0 squared plus 8 times 0 plus 25. Okay, so all this right here is going to get wiped away because we've got 0 squared. That's 0. 8 times 0 is 0. So at time 0, the height is 25. Now that might seem confusing. You're like, hey, Mr. YouTube Math Man, how's that possible? Did you jump up in the air and then like throw the ball? No, this is entirely possible because maybe this describes a situation where you might be on the top of a building or like, some sort of like, near edge of a cliff and you're throwing this thing into a valley, right? So you could literally be throwing the ball at a height of 25 and then the ball would go up and then continue to go back down past this height. So that's perfectly fine. I just want to make sure you understand that. Okay, but this, again, is how you use a function to figure out, what is the height of the ball given various time intervals, right? So if I wanted to find the height of the ball at 1 second, I would find h of 1. Okay, so I would just plug in and do the respective number crunching. I'm not going to do this math, but you can just see how we would do this. Okay, so the problem is what time, okay, how many seconds is it going to take in order to get to this top point right here? So we need to find the vertex. Now the seconds, let's just kind of go down here. This axis is the seconds or time. It is basically lined up with the x-axis and the height is lined up with the y-axis. So we can think in terms of x and y, but we want to find this vertex point, x and y, where an x, our x value, is actually our time in seconds. Okay, so let's go ahead and do the number crunching, and we're going to apply this formula right here, minus b over 2a. And you might not know what b and a is. That's perfectly fine. But I will explain this. If you're familiar with using the quadratic formula, and we're talking about a, b, and c values, well, these are the same a, b, and c values here. Okay, so let's go ahead and take the next step, which of course is having you quickly subscribe to my YouTube channel. Now, you might already be like, boy, Mr. YouTube Math Man, my brain is already hurting here. I don't really like this. And can you please hurry up and finish the problem? Well, indeed, I will. But I want to encourage you that if you have to learn math and you come across problems like this, problems like that are, interesting, okay, are often challenging and they're going to take time, they're going to take work. So if you think that every single math problem is going to be fast, easy, and simple, well, it's not. Okay, now, of course, if you are more advanced in mathematics and you know calculus, you can do this problem easy, one, two, three. But if you're an algebra student, algebra 2, college algebra, you just simply have to kind of work the process. Okay, but you can do this stuff. And my channel is all about math encouragement, right? Basically telling you you can be successful in math even if you're having a tough time with it. You're just going to have to study hard and really and try to find someone that teaches you math in a way you like and understand. So I need your support to continue to grow my channel and help as many people as possible. So the best way to grow my channel on YouTube is to have you subscribe. That's the only thing you need to do. And if you're going to do that, you might as well hit that notification bell as well. And if you need full-on math help and you really like my teaching style, well then check out my full main math courses. You can find links to those in the description of this video. What we're talking about here you could find in my Algebra 1 class, Algebra 2, etc., etc. And if you want to pick up a pair of study notes, check out the link to my Shopify store. You'll see it in the description as well. If you like to kind of have printable materials, something handy to learn some math on the fly. Okay, so let's get back to finishing this problem. And here is the situation. So here's our function, and basically what we're focused in on is finding the vertex of the parabola to this quadratic equation, this quadratic function. And we know there's a negative sign in front of the x squared or t squared. So our parabola looks this way, and it makes sense because the ball is going in this direction, right? It's not going to travel like this. We're not the ball, unless you're on some other planet where gravity works differently. It's traveling, in this direction. So it makes sense to have this negative right here. Okay, so what is a, b, and c? Well, our quadratic function has to be written in standard form. That means highest to lowest power. So when it's written from highest to lowest power, in other words, x squared or then x and then c is just a number, here we have t squared, t, and just a number. The coefficients or the numbers in front of the respective variables is our a, b, and c value. So here we have a negative 1 in front of t squared, so that is going to be our a value. Okay, what's in front of t? Okay, well, that's going to be our b value. So that is 8, and we don't need c. And if we needed c, it would be 25, and then we have all our values to use the quadratic formula to solve this quadratic function, which is a whole nother topic, but we're just going to focus in on the vertex. All right, so we have A and we have B. Now we get to plug all this stuff into our lovely formula for the vertex. All right, so this vertex point is going to be at some order pair, x, y. So the x here is minus b over 2a. Okay, great. What's minus b? Well, this is going to be minus 8, right, over 2 times a, which is negative 1. All right, so you got to be very careful here because we have these negative values. So let's get the x value first. So x is equal to minus b over 2a. Again, b is 8, excuse me, not a, 8, and a is negative 1. All right, so I know there's a lot of math going on here, so you can pause the video just to see what's going on. So we have negative of a positive a, that's negative 8, and then 2 times negative 1 is negative 2. So we have a negative divided by negative, that's going to be positive. Negative 8 divided by negative 2 is a positive 4. Now, again, you don't have to get the entire vertex to answer the question because the x-axis, remember, is the axis we have for time in seconds. So there is our answer for seconds. But let's go ahead and get the height just in case that was part of a question. So the time to maximum height is 4 seconds. But if we wanted to know, hey, what is the actual height at 4 seconds? We'll just plug in this 4 into our function, which is basically the second part of this vertex formula. Okay, so to get the y coordinate, we have to just plug in our answer for this into the function. So hopefully it makes sense. So let's go and do that simple math. So we're going to find h of 4, right? What is the height at 4 seconds? So we're going to plug in 4 into our function. We're going to replace the t for 4. Now we have negative 4 squared. Be careful, we got to take the powers here. 4 squared, 16. That's going to be negative 16 plus 8 times 4, 32. So negative 16 plus 32 plus 25, we're going to get a positive 16 here. Plus 25 is 41. Okay, so this particular ball, 4 seconds in, will be 41 feet. All right, so hopefully you learned something from this video. That's the whole point of me making these videos. And if you stuck with me this entire time, that's pretty impressive. And I try to make a connection with calculus because some of you probably took calculus, or, a lot of you probably studied a lot of math, but it may be, 10, 20, 30, 40, 50 years ago. And you'd be like, oh, Mr. YouTube Math Man, I used to be so good at math. You should have seen me way back in 1963. I'm sure you were awesome. But here's the thing. If you want to relearn math, it just, we're going to tend to forget just too many details. So if you're trying to get back into math, you could definitely relearn it, but you're going to have to find a good spot to kind of start learning. I would suggest if you are interested in relearning mathematics, check out my Math Skills Rebuilder course. I literally start from basic math and go from there, kind of build you up to get into algebra, geometry, even some basic trigonometry, and some other things as well. Okay, so with all that being said, I definitely wish you all the best in your math adventures. Thank you for your time and have a great day.